Hello and welcome to the Blue Open Studio tutorial video series. The topic of this video will be using tags. In this video, we will be discussing the purpose of tags in Blue Open Studio, the tags database, tag data types, properties, and scope, the data flow of tags, and tag housekeeping. We will demonstrate creating tags, arrays, and classes. Blue Open Studio does not use device or PLC I/O addresses or registers. Instead, it uses tags. And in fact, the only place that PLC I/O can be configured is on the driver or communication worksheets. Other than that, tags are used throughout the application. And how these tags are stored and configured inside of the application is with the tags database. So we'll talk a little bit now about the tags and the project or tag database. The tags are the core component to any Blue Open Studio application. Simply put, these are the variables that allow the Blue Open Studio application to send and receive information or data from field devices over communication, driver worksheets, or OPC or DDE or anything like that. They also can store the results of calculations and functions through scripting, animation, or basic math worksheets, and also can store data from user input, a button or a data display on the screen. And in turn, these tags are also used to display the information on the screens and also web pages, but also allow you to send that information back down to devices and also thin clients, and also will allow you to manipulate the screen objects and to control runtime tasks through animation or, once again, script or math worksheets. But the tags are more than simple variables. The tag database or the project database in the Blue Open Studio application is a real-time manager for the tags that provides several additional functions, such as storing the timestamp of a tag when its value changes, checking the values of the tags between a runtime minimum and maximum values that a user can define in development but also during runtime, and also comparing the tag values to alarm limits. And this is different than min and max value. They are values that can be configured for different alarm thresholds. And when we discuss alarms in another video, we will see that in action. A tag in a Blue Open Studio application not only has a value, but also this list of numerous properties associated with that tag. Some of these can be accessed only during runtime, others are exclusive for development, but usually the majority of them can be accessed in both. And an easy way to figure out what properties can be accessed from which feature is to look in the help manual. So if I bring up the help manual here and I type in tag properties, if I search the results, I should find an entry, complete list of tag properties. This list is all of the tag properties that are available for each tag. And in this table, it tells you the property name, description, whether it's read only or read and write, the data type for the property, the data type of the tag, and whether it's retentive. All tags are organized into one of the following categories. There are project tags. These are the tags that a user will create during the application development. And these tags include screen tags, tags used for device or PLC communication, control tags, meaning tags that will toggle scripting or in the schedule or math worksheets, and auxiliary tags that are used to perform these calculations, meaning in the background tasks, anything that will store the data from a mathematical equation. Then we have shared tags, which are stored in its own separate database. And these are tags that are created in PC-based control programs such as Steeplechase and then imported into the Blue Open Studio application. They're treated just like project tags, however, they are stored in their own separate database and cannot be modified inside of the Blue Open Studio application. If any of those tags are changed or removed, or if any tags are added, it has to be done in the third-party software and then the list re-imported in to Blue Open Studio. And then we have system tags. And these are predefined tags with predetermined functions. And these are typically the tags that are used for supervisory or control tasks for not only the application, but also for the software itself. So for example, date and time, there's a blink fast and a blink slow that will toggle at a certain interval. And then there's a second counter, there's a display scan. And most of these tags are read-only, meaning you're unable to write to them, but they are very useful for things like scheduler worksheets or creating simulations through scripting. Tag nomenclature. Basically, this is the syntax of how tags are structured inside of Blue Open Studio. And there are a few rules that you have to adhere to. The first thing is you must begin a tag with a letter. After that, you can use any combination of letters, numbers, and the underscore character. That's it. No other special characters are allowed. And there is a maximum of 255 characters allowed for the tag name. And application tag names must be unique from all other tag names, meaning system tags, and built-in function names. But tag names are not case sensitive. Unlike in GP Pro EX, where if you make a symbol variable uppercase, and then you decide you just want to capitalize the first letter, that is a different tag based on case. In Blue Open Studio, I could make my tag all caps in the tags database, and then on a screen object, I could enter in that tag all lowercase, and it will link to the same tag because it's going by the text, not the case. And we have several tag types available inside of Blue Open Studio. The first is a Boolean. This is a true, false, 0, 1, on, off, however you want to define it. And this is a single bit. And then we have integer. This is the standard 4 bytes for an integer, and it's signed, meaning it is negative, positive, or 0, and it's the equivalent to a C-type signed long integer, a range of just under negative 2 billion to just over positive 2 billion. Then we have reals, which are floating points, and they're 8 bytes. And the real number is internally stored as a double word, equivalent to the C-type double precision floating point. And then we have strings. It stores alphanumeric data up to 1024 characters, and a character string up to that length from 0 to 1023 that holds letters, numbers, or special characters. And Blue Open Studio applications support both ASCII and Unicode characters. A few more additional tag types. Now we get into the special tags, starting with arrays. And if you're not familiar with arrays, they are essentially a set of tags that are all the same data type with the same name that use an index number. Usually it is a static number that uniquely identifies each element of that array. At this time, Blue Open Studio only supports one-dimension arrays. And the structure or syntax would be the tag name, and in brackets would be the array element. Now, typically, this would be a static value. However, in Blue Open Studio, you can insert a tag name for the array element and dynamically set which element you are either displaying or writing to or reading from during runtime. And arrays in Blue Open Studio are zero-based, meaning that the first element is 0. When we go to enter in tags in the tag database, there is a field called array. And in that field, the number you enter in there is not the total number of elements, it is the maximum array element. So for example, if you put a 10 in there, you will have 11 array elements because you start from 0 and you go to 10. Then we have classes. And a class tag is a compound tag that consists of several different members that can be different data types. And these are helpful when developing an application that has several properties in a single item. For example, a tank. So you would have pressure, a fill level, temperature, whatever the case may be. And the structure is the tag name dot class member. And note that the maximum number of members for each class is 512, as long as that does not exceed the maximum number of tags that are supported by the license or product type selected for the application. And to learn more about that, please refer to our Licensing the Software tutorial video. Additionally, for classes and arrays, that maximum number of characters of 255 for the tag name comes into play here. So let's say that you have a tag that is configured as a array class. So you would have the tag name, and in brackets, you would have the element, and let's say you're using a tag name for that element number as well. And then a dot, and then a class member name. That entire string of characters that identifies that tag cannot exceed 255 characters. And last but not least, we have pointer tags. And these are tags that allow you to indirectly reference another tag inside of the Blue Open Studio database. And the syntax is the @ sign and then the tag name. And essentially how this works is that pointer tag name is typically a string data type. So Blue Open Studio will look for the value of that tag as the tag name to look at in the database to get the value from. And then we get into the tag properties. And as I mentioned before, these are pieces of metadata that are associated with each project tag in the database. Most of the time, you may think of these project tags as simple program variables, kind of like in GP Pro EX with symbol variables. However, not only do they store values, but they have much more information that they are able to collect and display and use for whatever processes you see fit. And typically these are different data types, as we saw in the tech ref, and they are handled in different ways during the runtime depending on how your tags are configured. And in addition to handling the standard metadata like the array size or data type or your description and scope, they can also be used to configure alarm conditions, get the quality of the tag if it's connected to a PLC address through a driver worksheet. You can convert between different units of measurement. You can access individual bits of that tag, and you can also set it during runtime to retain values through a project restart instead of reinitializing back to 0. And the syntax would be the tag name, dash or minus sign, and then greater than sign, and then the property name. Once again, this falls under the 255 character limit for tag names. So if we take that example of a class array tag and we wanted to get a property of that specific tag, that entire string will need to stay within the 255 character limit. In tag scope, essentially what this means is that this allows you to determine where the tag lives, either globally, meaning that it resides on the project server and all of the information is shared, or locally on each station where the data is exclusive to each one of those stations. So the two settings are server, which is the default, and this is where the data is shared between each station. So if the tag value changes on station 1, that will be reflected on all the other stations and the project server. And the local scope means that each station has its own virtual copy of the tag and is maintained in its own exclusive tags database. So if the value of that tag changes on station 1 and the scope is set to local, that value will not change across the other stations. It will remain changed just on the single station. For the tags database manages this flow of data between the different modules or tasks. In addition, the tags database stores all of the tag values and statuses of the properties associated with each tag, the alarm conditioning, timestamp, quality, what have you. Each runtime module contains a virtual table of the relevant tags for that module, and the tags database uses this table to determine what information must be updated in each module. For example, the viewer contains a virtual table that lists all of the tags configured for all of the open project screens. And if a tag value changes, the tag database then sends the message to the viewer, and then the viewer updates the value on all objects where the tag is configured. Let's say, for example, we have a Modbus device communicating to the Blue Open Studio application over Ethernet. Then we have this tag used in a script, so a background task. And then we also display it on a data display on a screen. So we read the value in from the Modbus device. That would come in through the driver runtime into the tags database for Studio Manager.exe. We would then send it through a background task through a script to validate the information and do whatever processing we need to do to it. It would then come back in through the background task to the database, and then out through the TCP/IP server task to the viewer.exe. It will then display it on the screen. We will, let's say, push a button or use a data display to modify the value, and then it would read it back in through the TCP/IP server into the tags database. And now we need to write it back to that Modbus device we're communicating to. So then it would go back out through the driver runtime and write the value back to the Modbus device. This table displayed here can be found in the technical reference or TechRef. If I go to the Contents tab under Introduction, Internal Structure and Data Flow, and if I scroll down, I see that diagram of the architecture for the project runtime. Additionally, this gives me some more information about an example of data flow and a breakdown of all of the different tasks or modules for the internal structure. With the necessity of using tags in the application, there will come a time when tags may no longer be used, or we have to trim down the amount of tags that we have, or we need to find where certain tags are used inside of the application. This is where these housekeeping functions come in. And there are several utilities that can be used to manage the number of tags and to find where they are located in the application. The first is the Global Replace tool. And this allows you to replace any tags throughout the application in any document. This would be screens, driver worksheets, script, any application or project screens that you've created. A helpful note, when you change the tag name in the project tags database, Blue Open Studio will automatically ask you if you intend to replace the tag throughout the whole project. If you say yes, it will then perform a global replace throughout the entire application, replacing the old tag name with the new. Then we have the remove unused tags, and this is extremely helpful, especially when you have to keep track of the amount of tags you're using and stay within a certain limit. Essentially what this does is it runs a cross-reference for the entire tags database against the application. It finds where every tag is used in the application, and any tags that are not used a single time, it then displays on a list that you can select to remove. You don't have to remove all of them, you can select which ones you want to remove. But an important note for this is unused tags are tags that have a defined location in the project database, but are not used in any screen or task worksheet. And since your application has a limited number of available tags, this is determined by the license or product type that you've selected for the application. And an important note is tags that are used in functions that are indirectly addressed. This applies specifically to scripting, which we will cover in another video. For example, the set tag value function, you have to put a tag name inside of quotes. This is considered an indirect tag addressing. These are excluded from these utilities, the global replace and the remove unused tags. Additionally, they are excluded from the cross-reference as well. Then we have the reset tags database. Essentially what this does is reloads or reinitializes the tags database on the local station. And this affects all tags that are stored in the project tags folder. This option is useful for resetting the project tags and restoring the values when the application was loaded for the first time. So let's say that you test an application, everything looks good, you're ready to deploy. You would then, in development, click on this utility to reinitialize all the tags back to their default values. And now you're able to deploy it on a system without having any preloaded data in the application. And the reason this is useful is because when the application or project is stopped, but you leave the development environment open, the tags are not reset by default. And when the project runs again, these values are essentially the startup values. Therefore, you can execute a command that you may not want to. It may be unintended that that value is there. So by using this reset tags database, you can reinitialize all of those tags and not have to worry about accidentally running a command on startup. And when I say reinitialize or reload, that doesn't necessarily mean resetting them to 0. There is a startup value that you can configure for the tag. And this startup value is what the tag is reinitialized to. However, if you do not configure startup value for a tag, they will be set to the defaults. For numeric tags, those are booleans, integers, or reals. It's a value of 0. For string tags, it is an empty string. Continuing with the reset tags database, there are a few notes. The tags stored in the system folder and the shared tags folder are excluded from this command. If you want to reset the project tags automatically whenever the project or the runtime is started, you can go into the options for the application and select the Reset Tags Database checkbox. Whenever the project starts, it then reinitializes the tags back to their default value. So now we will demonstrate adding classes and then tags to our Blue Open Studio application. So the first thing I want to do is on the Project Explorer, go to Global, and then on the tree list I see Classes. I will right click and select Insert Class. And you see with the caption in the upper right hand corner, I have 3 classes I'm going to add. The first I'm going to name C List, and once I hit enter, I see a worksheet or the datasheet view appear for the class. And it is structured with 3 columns. The first is the member name, the second is the data type, and the third is a description. Only the name and type fields are mandatory. Description is optional. So for this first one, I'm going to create the C list. So my first member will be read. I will then tab over, and I can drop this down, and I see my 4 basic data types. For this one, I want to set it to integer. You see, as soon as I select a data type, I have an icon appear next to the member name. This also applies to tags as well. And what this does is this is a quick indicator of what the data type is for that member or tag. So you don't have to come back into the tags database to see what the data type is. The second item will be user enable, and that will be a Boolean. The third will be control enable. This once again will be a Boolean. And the last one will be write, and this one will be a string. And you can see that I am changing the data type not by using the mouse. I am simply hitting the first letter of whatever data type I need to use. So for string I hit S, for Boolean I hit B, for integer I would hit I, real would be an R. I have my class configured. There is no saving that's required. I simply come up here and I click on close for the tab, and if I expand my classes, I now see my C list class show up. If I expand this, I can either expand the member list to see the individual members and their corresponding data types based on the icons, or I can double click on the datasheet view to get back into the actual modification of the tags. We need to create the other 2 classes. And what I have done is in the training file zip folder that was downloaded in a previous video, we have an Excel file in there that contains all of the classes that we want to create. So what I'm going to do is I'm going to open Windows Explorer, and I'm going to double click on my C drive because this is where I extracted the training files, and I see the BOS training tags.xls. I'm going to open this file. I will close Windows Explorer. I will then snap the Excel file to the right of my screen, and then I will snap Blue Open Studio to the left. And now I will create the other 2 classes. I will right click on classes, select insert, give it a name of C driver, and now I'll come back to the Excel file, and I will skip the first 2 rows because that is just the class name and the headers for the columns. I will select the rest, copy, come back to Blue Open Studio and paste. As you see, all of the member names and the data types came over, pasted in properly. And as long as the order, the syntax, and the spelling is correct, especially for the data types, you're able to copy and paste between the worksheets in Blue Open Studio and Excel, or even Notepad or any other text editor. This is extremely helpful for doing quick moves or modifications or changes or additions to not only classes but tags. Now that my driver class is created, I will just simply close it. Right click again on classes, select insert, give it a name of C, sushi. Once again, come back to the Excel file, copy, and paste them in, and then close my class. We have the classes created. It is now time to move on to creating the tags. So the first thing I will do is come to the Project Explorer, and I will expand Project Tags, and double click on Datasheet View. And I will maximize Blue Open Studio so we can see the columns better. So what we have is a similar datasheet layout as we saw with the class creation, only this time there are a few more columns. We have name, which is the column name for the tags. We have the array field, which we've discussed previously. This is where we put in the maximum element for the array if we choose to create a tag as an array. If you leave it blank, then it's just a single tag. No array is configured. We have our data type field, our description, and our scope. Once again, just like in creating the class members, the only pieces of data that are mandatory are the name and the data type. Scope is automatically defaulted to server. So what I will do now is I'll snap Blue Open Studio back to the left side of the screen. I'll come back into the Excel file, go to the tag list worksheet, and we see my tags listed there. So I am going to first manually create a tag, which will be the top one, which will be list. Just type in list, leave array at 0. And for data type, I will drop this down, and you can see that my classes are listed at the bottom. And many of you are probably wondering why I put a lowercase c in front of the class name. It is so I can tell what data types I've created as classes versus the standard data types. So for list, I'll select C list, and then I will come over to scope and set it to local. I don't like the fact that I have to scroll, so what I'm going to do is I'm going to shrink description down so everything fits on the screen. As you can see, the icon for list turned into a folder. That signifies that it is a class data type that I've selected for this tag. So what I will do now is simply copy out of the Excel file sushi, MDV, and SDV tags, copy those, and then paste them in. They come in properly, and then I will manually enter in the next one, which is main PLC. We'll then set the array to 10. And as you see, as soon as I entered in a value other than 0 for array, my icon for the data type is encapsulated inside of brackets. That signifies that this is an array of integers in this example. We could set it to bool, we could set it to string, and as long as it's encapsulated inside of those brackets, that signifies that it is an array. Then I will set the scope to local. Now I'll come back over, copy the other two, and then paste them in. Thanks for watching. If you have any questions, please feel free to contact ProFace America Technical Support by phone at 1-800-289-9266, option 2, or by email, support@profaceamerica.com. You can also visit our website, profaceamerica.com, for manuals, drivers, product FAQs, and other product and software information. Thanks again, and have a great day.